This is the diagram given for example 7, and we are asked to find A1, A2, T1, and T2. Now, we know that the acceleration is going to be the same for both masses because they're on the same rope. So whichever acceleration one is going at, the other one will be doing the same thing. I will also note that M1 equals 10 kilograms and M2 equals 100 kilograms. So first we'll look at finding T1. So first I made a quick error. This will be M1 and this will be M2. So when we are solving for T1, this represents our tension and this can represent the force of gravity on the object. And we can see that the tension's in the positive direction and the gravity's in the negative direction. So T minus mg will equal m1 times a, the mass of 1 times a. Because don't forget, this will be the sum of all the forces, and the sum of all forces equals mass times acceleration. For T2, the tension is shown here, and this represents the tension in the negative direction, and this represents gravity but in the positive direction, and the tension's in the negative direction. So we will write mg minus t equals m2a. And if we combine these two equations, we will find that the t's cancel out. The masses do not cancel out because m1 and m2 are different. So we will get m2g minus m1g equals m1 plus m2 multiplied by a. And because we're looking for the acceleration, we will divide m1 plus m2 from both sides, and our acceleration will equal, we can factor out the g, m2 minus m1 divided by m1 plus m2. And because we have our values, we can solve for a. Gravity is 10, m2 is 100, m1 is 10, m1 is 10, and m2 is 100. And our answer, if you put it in your calculator, turns out to be 8.18. Now that we have found our acceleration, and remember we said that our acceleration will be the same for both objects, we can plug it in to our first equations, and this will help us find t. So let's start with T1. T1 equals, T1 minus m1g equals m1a, which can be rewritten as T1 equals m1a plus m1g. T1 equals m1, 10, times 8.18, our acceleration, plus 10 times gravity, 10. And T1 will equal 181.8. And we can take the same steps to solve T2. So m2g minus T2 equals m2a. We can do negative T2 equals m2a minus m2g. T2 equals m2g minus m2a. And we can plug in our values, and we know that T2 will equal 100 because our mass of 2, our second mass is 100 times 10 minus 100 times 8.18. And our T2 will equal 182. And now we have found T2, T1, and our acceleration.